let's practice discussing the relationships between volume, pressure, and temperature of an ideal gas. We can think about these relationships both mathematically and conceptually. Let's first think about them mathematically. Because it's an ideal gas, we can refer to the ideal gas law, which is PV equals nRT. P, of course, is our pressure. So let's first think about these relationships in terms of pressure. If we increase the pressure of the system, what must happen to V, our volume? It will decrease. Let's use an example. If we have 1 unit of pressure and 1 unit of volume on the left side of our equation, what happens when we increase our pressure by a factor of 10? In order to maintain a constant state, our volume will decrease by a factor of 10. This is called an inverse relationship. So if this is an inverse relationship, what happens to temperature when we increase pressure by a factor of 10? It will also increase. So in this case, we have 1 unit of pressure on the left side of the equation and 1 unit of temperature on the right side of the equation. So in order to maintain the same state across the equation, if we increase the pressure by a factor of 10, we must increase the temperature also by a factor of 10. So this is called a direct relationship. So we now know that pressure and volume have an inverse relationship, but what about the relationship between volume and temperature? Let's continue by assuming we will decrease our volume by a factor of 10. What happens to our temperature? This will also be a direct relationship. So our temperature will also decrease by a factor of 10. So in that case, we have 1 factor of volume and 1 unit of volume and 1 unit of temperature. If we decrease the volume by a factor of 10, we must also decrease the temperature by a factor of 10. Now I'll give a conceptual example. So we see the 2 boxes below. We're starting with a set volume on the left side of the equation. So let's call this 10V. And we're decreasing it by a factor of 10. So we have 1V. And we're going to have 4 molecules of gas inside the box. And they are colliding with the constraints of the box to give us a pressure of 1 atmosphere. So let's think about this more mathematically or using the correct units. So that would be 10 liters going down to 1 liter. So we're decreasing by a factor of 10, but we're using the correct units of liters. So for this example, we're going to remain with our 4 molecules of gas, but now there are more collisions with the sides of the container because the volume is now smaller. So our pressure must increase because of that inverse relationship. And this is a good conceptual example to show why this occurs. So now we have 10 atmospheres of pressure.